Here's our final lesson on binomial theorem. Not only can you use it to expand a binomial to any power you like, you can also use it to find one specific term. So to illustrate how we do this, I'm going to go back to some of the first examples we looked at. Here's a problem we did in the last video where we expanded quantity x plus 1 to the 10th. And I want to highlight a few patterns that emerge when we do this. So let's look at the third term, for instance. 10c2 x to the 8th 1 squared. This is the third term. And notice that the number of the term is one more than what we take NC of. Third term, we have 10C2. Fourth term, 10C3. We're one less. Whatever term number we want, NCR is one less of that term position. Also notice the power of B, in this case B is 1, is equal to 10C, this number. So this corresponds to an entry in Pascal's triangle. That position matches this power. And then this power we can get by recognizing that we have 10 total. Here I've used 2, so this will be 8. That is pretty much the secret, if you will, as to how we can find one specific term. I could do that here. Here is the fourth term. This is the fourth term. One less than the fourth position, that's 3. And then here's 3 powers in B. Here's the, oh, look at this term. There's the fifth term. 1, 2, 3, 4, fifth term. 5C4, and then 4. So if we apply that to this particular problem, we can find this specific term without multiplying out, without knowing any other terms nearby. So let's apply that. Fifth term. That means I will have 8C, 1 less. The reason it's 1 less is because first term is NC0. Second term, NC1. Third, NC2. So we're always off by 1 between the position and the value that goes here, because we're not starting at NC1, we're starting at NC0. So we're always going to have a gap of 1 there. Fifth term would be NC4. So I know that in this problem, I have 8C4 in front of the fifth term. I have x to a power, and I have 3 to a power. This value matches the power of 3. I have 8 powers total. I've used 4 of them here. That means x gets 4. There's the basic setup for the fifth term in this problem. Now it's just a matter of calculating 8C4. 3 to the 4th is 81. And we get that this particular term is 5,670 x to the 4th. We have found one specific term without finding the entire expansion. Let's take a look at another one. X minus 2 to the 15th. Let's say that this binomial is the model for some set of data or something that's been modeled. It's a good approximation of a particular model. And you just want this specific position, that spot in the model. Find the 8th term. 15C 1 less times x to a power -2 to a power. Well, -2 will be to the 7th because it has to match this value right here. I have 15 powers total. -2 gets 7 of those. X will get 8 of those. And now it's just a matter of finding the coefficient, which will be 823,680 x to the 8th. A little big. We did that in under a minute. Find one specific value of this expansion. One thing to be cautious of, 8th term does not mean x to the 8th. 5th term was not x to the 5th. Nor is it x to the 1 less. It's just x to whatever power is needed to bring these up to whatever this is. One more example. This says find the coefficient of x to the 4th. And if you do not recall what coefficient means, it's the number in front of the variable. 3 is a coefficient. 823,680 is a coefficient. It's just, what is the number? How many of that power do you have? How many x to the 8th do you have? That's another way of thinking about a coefficient. How many of that particular value? How many of that particular object? We're looking for x to the 4th. Okay? So I have x to the 4th times 1 to the 6th. I know it's 1 to the 6th because I need 10 powers. I know that x to the 4th is going to be part of this. That means I need 6 more powers to bring the total powers up to 10. What I don't have is my NCR. I know it's 10C something. Well, this number has to match this power. It's 10C6. And now, because it's a coefficient, I can get rid of this. I was just there to help. Don't need a double multiplication. 10C6 times 1 to the 6th. The coefficient is 210. So in other words, this term, if it said find this term, the term would be 210x to the 4th. Since it now just says coefficient, we're just doing the number, looking for the number. And that is all there is to finding a specific term. Make sure you do the completion quiz for this lesson, and after that, look for a little mini unit assessment for this little mini unit.